So one last thing, and this is about the homework. All right, so new video. This is about the homework. Everything's, I need to get everything settled out with how I'm doing this, because it's been a while since I've done it orchestrated rather than just like a Google Meet or something. So we have this homework problem, and I had a student email and say, I keep getting the chrome bumpers as a higher temperature. And I just want to point out that I was wrong. At least think about what's going on here. Right? I have one object, E equals 1, and it absorbs 950 watts. And we'll say its area is 1 meter squared, which is what I intend. Right? Is that a pickup truck is obviously larger than that, but it's 950 watts per square meter. So if it's 10 square meters, then it's 9,500 watts. Right? So that's what it absorbs, right? Because it absorbs everything. And then you come up with some temperature for it from radiation. Right? So another object over here, E equals 0.3, if it absorbs 950, then it has to bounce some out, right? And it ends up being 950 divided by 0.3 ends up being 3160 watts times 0.7. So 2220 watts. All right. If it absorbs 950, but it only absorbs 0.3 of the total, then the total's 3160. And it reflects 2220. So, if that's the case, then this thing absorbing at 950 watts, it's going to end up making the temperature higher. Right? Because when you solve this problem out, you're going to get this emissivity on the bottom of a fraction. So this dropping to 0.3 goes up. The other way of thinking about this is it doesn't absorb this. The other way of thinking about this is to say that the sun is out, you're in a parking lot, 950 watts per meter squared. This thing, E equals 1. This other thing, E equals 0.3. And so if you consider that, what gets into this one is 950. What gets into this one is 0.3 times 950. 950 times 0.3 is 285 watts. That's when the temperature's lower. All right. So if the chrome actually absorbed 950 watts, the temperature would be a lot higher because there'd be more energy and it's absorbing the full 950. But if 950 is what the sun puts out, right, and then you have two objects and you're comparing them, well, the chrome absorbs less. It doesn't absorb the 950. So you have to be careful there. If you understand the problem one way, then I'm wrong. The temperature should be higher. If you understand it the other way, then you have to realize the object doesn't absorb the full power. So I'll leave that to you to look at and translate, and I'm going to be lax on that problem. Is that show me you can do the calculations, show me that you understand what's going on there. All right, if you get a higher temperature, show me that this is your understanding of it. Okay, I'm not going to tell you what those temperatures are, but they're consistent with a parking lot being hot. All right, so hopefully I see you guys on Monday.